A quiet warning from Chinese researchers just shook the satellite world. Planet Labs Dove. A satellite swarm might be turning into low-cost orbital landmines. But what exactly does that mean? In this video, we're diving into the groundbreaking findings behind this claim, how researchers discovered hidden threats in orbit, and why this changes everything about how we see space safety. You'll learn what went wrong, why it matters for every future launch, and how this signals a major shift in how we manage our skies. Planet Labs has dramatically changed the space industry by launching over 600 small satellites, known as Doves, into low Earth orbit. These CubeSats are about the size of a loaf of bread and weigh just 5 kilograms each. Despite their size, they pack serious capability. They capture near-daily images of Earth's surface, helping governments, researchers, and industries monitor everything from climate change to crop health and urban expansion. This isn't a story about failure. It's one about success leading to unexpected consequences. The sheer number of satellites launched by Planet Labs was a first. Instead of a few large, high-cost satellites, Planet sent up dozens at a time, creating a swarm of low-cost, mass-produced spacecraft that made Earth observation more accessible, but also introduced new risks. By mid-2025, over 80% of these satellites had already deorbited. While that might sound like business as usual, many of these deorbits happened without proper tracking or identification. More than 100 of these satellites were found to have incorrect or missing data in public tracking catalogs. Some were even listed with fabricated identification codes. That means they were essentially ghosts in orbit, hard to track, hard to predict, and potentially dangerous. The Dove satellites also lack onboard propulsion. This means they can't steer or dodge other objects once launched. When they stop functioning, they become passive drifters, still moving at tens of thousands of kilometers per hour. Without precise tracking, these tiny, powerless spacecraft become potential obstacles in a sky already filled with activity. The strategy of launching large numbers of inexpensive satellites has reshaped how we use space. But it also created a new kind of challenge: volume. When dozens of satellites enter low Earth orbit with short lifespans and limited tracking, even small inconsistencies in their paths can raise the risk of collisions. This is where the problem begins. Even if each satellite individually poses little threat, together they crowd orbital lanes. It's not about size, it's about scale, behavior, and visibility. That's what led scientists to label this situation as a growing, invisible danger. And it's only just beginning. So what exactly is an orbital landmine? It's not just a catchy term. It's a serious concern rooted in detailed analysis. Chinese researchers used their orbital tracking systems to investigate Planet Labs Dove satellites. Their conclusion? Many of these small satellites, though built to be low-cost and disposable, are turning into hidden hazards. Here's how. First, remember that Doves don't have propulsion. Once deployed, they follow their preset path until atmospheric drag slowly pulls them down. This process might take months or years, depending on their altitude. But during that time, if a satellite malfunctions or its tracking data becomes unreliable, it can float in orbit unnoticed, even if it's no longer functioning. That's where the metaphor comes in. An orbital landmine is a satellite that seems inactive but still poses a danger, just like a landmine waiting to be triggered. It drifts silently through space, potentially in the path of other working satellites. If two objects collide, even small ones, the result is catastrophic. Fragments can fly in all directions at extremely high speeds, creating more debris and raising the risk of additional collisions. Researchers identified more than 100 Doves with inaccurate or missing information in public space tracking databases. That means these objects were either incorrectly labeled, had mismatched IDs, or didn't have reliable orbital data. Imagine driving through a foggy highway where over 100 vehicles have no lights, no license plates, and don't respond to traffic systems. That's the level of unpredictability this data gap creates in space. Another part of the problem is speed. Satellites in low Earth orbit travel at nearly 28,000 kilometers per hour. Even a paint chip moving at that speed can damage a spacecraft. Now imagine an untracked 5-kilogram satellite crossing paths with a large, expensive imaging satellite or a crewed spacecraft. The risks multiply. This doesn't mean CubeSats are bad. They've enabled some incredible scientific and commercial advances. But as their numbers grow, the way we manage them must evolve. These findings reveal how vulnerable our orbital highways are to even the smallest breakdown in transparency and control. This situation is a wake-up call. It's not just about what we launch, it's about how we track, manage, and retire these objects. And right now, that system is starting to show serious cracks. The Dove satellite revelations expose a deeper issue. Space governance hasn't kept up with the pace of innovation. While space used to be dominated by a few major players with large, expensive satellites, the rise of commercial actors launching hundreds of small spacecraft has completely changed the landscape. The current rules for space activity are guided by broad international agreements, like the Outer Space Treaty. These treaties emphasize responsible use and accountability, but they lack specific technical requirements for how satellite operators must manage tracking or end-of-life disposal. For small satellites like Dove's, which don't have propulsion and are often deployed in large numbers, this is a critical oversight. Even at the national level, regulations often fall short. In many cases, CubeSats don't have to carry any active deorbit system. They rely on natural decay due to atmospheric drag, and that's only effective if the satellite stays where it's expected to be. But if a satellite's identification is wrong or its orbit changes unpredictably, the decay timeline becomes uncertain, and the satellite becomes harder to monitor. The Chinese researchers flagged this gap clearly. They found that some Doves continued to orbit long after their expected deorbit dates, without updated tracking. Others had completely mismatched IDs, meaning tracking systems could not recognize or update their positions. That makes it difficult for space agencies and satellite operators to plan around them or avoid them. Another issue is that current tracking systems rely heavily on operator-reported data. If a company submits incorrect or outdated information, it may go unnoticed for months. There is no global authority verifying every satellite's position in real time. This leaves critical blind spots in space traffic management. Why does this matter so much? Because low Earth orbit is becoming more crowded every year. Thousands of satellites are planned for launch in the next decade. Without standardized tracking requirements and real-time data sharing, the risk of collision and debris buildup grows rapidly. This situation doesn't call for less innovation, but it does demand better coordination. If companies, regulators, and space agencies don't work together to tighten safety standards, the very environment we depend on for communications, Earth observation, and science could become dangerously unstable. What started as a story about small satellites has turned into a challenge for the entire space community. It's time to rethink how we manage the sky.